Imagine a world encased in ice. The Earth was once a giant snowball, a frigid wasteland of ice and snow. This wasn't just a little ice age, it was the most extreme ice age our planet has ever known. Scientists call this period Snowball Earth. It happened about 650 million years ago. Back then, life on Earth was very different. Only tiny organisms lived in the oceans. The ice spread from the poles towards the equator, covering everything in its path. Soon the entire planet was locked in a deep freeze. The oceans were covered in a thick layer of ice, perhaps a kilometer thick. Yet somehow, life found a way. The Snowball Earth period is one of the most fascinating and mysterious chapters in our planet's history. So how did Earth become a giant snowball? Well, it wasn't a sudden event. It happened gradually over millions of years. The Earth's climate is a complex system driven by many factors. One of the most important factors is the amount of carbon dioxide in the atmosphere. Carbon dioxide is a greenhouse gas. It traps heat from the sun and keeps the planet warm. But during the Snowball Earth period, something happened that caused the levels of carbon dioxide to plummet. Scientists are still debating the exact cause. One theory is that a massive volcanic eruption spewed huge amounts of sulfur dioxide into the atmosphere. This sulfur dioxide reflected sunlight back into space, cooling the planet. Another theory suggests that the movement of the continents played a role. As the continents shifted, they affected the ocean currents and the distribution of sunlight, which could have triggered a global cooling event. As the Earth cooled, more ice formed, reflecting even more sunlight back into space. This created a positive feedback loop, accelerating the cooling process. The ice spread further and further, eventually covering the entire planet. The Snowball Earth period is a stark reminder of just how delicate our planet's climate system really is. The Snowball Earth event was a catastrophic event for life on Earth. Imagine a world where the oceans are frozen solid, except for a thin layer of water beneath the ice. Sunlight, essential for photosynthesis, is blocked by the thick ice sheets. Temperatures plummet to unimaginable lows. This was the harsh reality for the organisms that existed during this period. Most life forms during this time were simple, single-celled organisms living in the oceans. They were adapted to a world very different from our own. The extreme conditions of Snowball Earth pushed these organisms to the brink. Many species simply couldn't survive the cold, the lack of sunlight, and the limited availability of nutrients. Scientists estimate that up to 90% of all life on Earth went extinct during this period. But amidst this frozen wasteland, life found a way to endure. Some organisms found refuge in areas where there was still liquid water, such as hydrothermal vents on the ocean floor. These vents spew out hot water and chemicals from the Earth's interior, providing a source of energy and nutrients. Other organisms may have survived in areas where the ice was thinner, allowing some sunlight to penetrate. The survivors were the toughest of the tough, the ultimate extremophiles. The Snowball Earth event was a bottleneck event in the history of life. How do we know about this ancient ice age? We weren't there to witness it, but the Earth kept a record. The evidence for Snowball Earth comes from rocks that formed during this time period. These rocks are like time capsules, preserving clues about the Earth's ancient past. Geologists have found these rocks on every continent, indicating that the glaciation was truly global. One of the most compelling pieces of evidence comes from glacial deposits found in tropical latitudes. These deposits, known as tillites, are made up of a mixture of rocks and sediment that were transported and deposited by glaciers. The presence of these deposits in areas that are now warm suggests that the entire planet, even the tropics, was once covered in ice. Another clue comes from the types of rocks that formed during this period. The evidence from the rocks is clear. Snowball Earth was real, and it was a time of extreme environmental change. While the Earth was locked in a deep freeze, a force of nature was at work that would eventually lead to its thaw. Volcanoes, those fiery mountains that spew molten rock and ash, played a crucial role in ending Snowball Earth. Remember how the Earth froze over because of low carbon dioxide levels? Well, volcanoes are a major source of carbon dioxide. During Snowball Earth, volcanic eruptions continued to release carbon dioxide into the atmosphere. However, with the Earth's surface covered in ice, there were no oceans or land plants to absorb this carbon dioxide. It began to accumulate in the atmosphere, slowly but surely. Over millions of years, the levels of carbon dioxide rose, trapping more and more heat from the sun. This created a greenhouse effect, gradually warming the planet. The ice began to melt, exposing the dark ocean water beneath. The role of volcanoes in ending Snowball Earth highlights a crucial point about our planet. It's a dynamic system with interconnected processes. As the ice slowly retreated, life began to reclaim the oceans. The evidence for this resurgence of life is preserved in the rocks that formed after Snowball Earth. These rocks tell a story of adaptation, innovation, and the incredible tenacity of life. One of the most telling signs of life's comeback is the reappearance of stromatolites. Stromatolites are layered structures created by colonies of microbes, primarily cyanobacteria. Cyanobacteria are photosynthetic organisms, meaning they use sunlight to produce energy. The presence of stromatolites in rocks that formed after Snowball Earth indicates that there was enough sunlight reaching the oceans for photosynthesis to occur. This suggests that the ice had thinned enough to allow light to penetrate, at least in some areas. Another key piece of evidence comes from the diversity of fossils found in rocks from this period. The fossil record from this period provides a glimpse into a pivotal moment in the history of life on Earth. The Snowball Earth event, while devastating, may have actually paved the way for the evolution of more complex life forms. The melting of the Snowball Earth was not a gentle process. It was a time of dramatic climate change, with wild swings in temperature and sea level. Imagine glaciers the size of continents collapsing into the oceans, causing massive tsunamis that reshape coastlines. Picture torrential rains as the warming atmosphere dumped its moisture onto the thawing Earth. This was a time of upheaval and transformation, a planet in flux. As the ice sheets melted, they released vast amounts of fresh water into the oceans, disrupting ocean currents and altering the salinity of seawater. This would have had a profound impact on marine life, which had adapted to the cold, stable conditions of the Snowball Earth. The rapid climate change also led to extreme weather events, such as superstorms and intense droughts. The Thaw was a time of both opportunity and peril. The legacy of Snowball Earth is etched into the very fabric of our planet. The period following Snowball Earth was a time of remarkable evolutionary innovation. With the harsh conditions of the Ice Age receding, life exploded onto the scene, diversifying into a dazzling array of forms. Scientists believe that the extreme environmental pressures of Snowball Earth, followed by the dramatic changes during the Thaw, created a sort of evolutionary bottleneck. Only the most adaptable and resilient organisms survived, and these survivors found themselves in a world ripe for the taking. The melting glaciers opened up vast new territories for colonization. The changing chemistry of the oceans created new ecological niches, and the warmer temperatures provided ideal conditions for life to thrive. One of the most significant evolutionary developments during this time was the rise of multicellular life. These early multicellular organisms were the ancestors of all the plants and animals that exist today, including us. The period after Snowball Earth is often referred to as the Cambrian explosion, due to the sudden appearance of a diverse array of fossils in the geological record. The legacy of Snowball Earth is all around us. It is etched in the rocks, the continents, and even the very air we breathe. This ancient ice age shaped our planet and played a crucial role in the evolution of life as we know it. The extreme conditions of Snowball Earth, followed by the dramatic changes during the Thaw, created a crucible of evolutionary innovation. Only the most adaptable and resilient organisms survived, and their descendants went on to populate the planet with the incredible diversity of life we see today. The Snowball Earth event also had a profound impact on the Earth's geology. The massive ice sheets carved out valleys, sculpted mountains, and transported huge amounts of rock and sediment across continents. The evidence for this ancient ice age is preserved in the rocks, providing scientists with clues about the Earth's climate and the conditions that existed during this time. The Snowball Earth event is a stark reminder of the power of nature and the interconnectedness of Earth's systems. The Snowball Earth event provides valuable insights into the dynamics of our planet's climate system. By studying this ancient ice age, scientists can learn about the factors that can trigger abrupt climate change and the potential consequences for life on Earth. One of the key lessons from Snowball Earth is the importance of the carbon cycle in regulating Earth's climate. The buildup of carbon dioxide in the atmosphere during Snowball Earth, caused by volcanic eruptions and the lack of carbon sinks like oceans and plants, eventually led to the thawing of the planet. This highlights the delicate balance of greenhouse gases in the atmosphere and the role they play in maintaining a habitable climate. Another important lesson is the interconnectedness of Earth's systems, the movement of continents, the eruption of volcanoes, the evolution of life, and the composition of the atmosphere all interact in complex ways to shape the planet's climate. The Snowball Earth event also underscores the remarkable resilience of life on Earth. As we grapple with the challenges of climate change today, the lessons from Snowball Earth are more relevant than ever. The Earth's climate is changing at an unprecedented rate, driven by human activities that are releasing greenhouse gases into the atmosphere. While the exact consequences of these changes are still uncertain, the Snowball Earth event serves as a stark reminder of the potential for abrupt and dramatic climate shifts. By studying the past, we can gain a better understanding of the Earth's climate system and the potential risks associated with human-induced climate change. The Snowball Earth event is a cautionary tale, but it is also a story of resilience and hope. Life on Earth survived and even thrived after this extreme climate event, demonstrating the remarkable adaptive capacity of living organisms. As we face an uncertain future, it is essential that we learn from the past and work to mitigate the impacts of climate change. The Snowball Earth event is a powerful reminder that we are all connected to the Earth and its history.